In order to collect and process data, we must first build an instrument method. In MS Workstation, this is done by clicking on the method editor within the task pane here. This will open the last edited method. If we want to create a new method, we can either click here or we can go to File, New. This will then take us through a configuring method guide. We can click Next and then choose which instrument we wish to use. Here we can then decide if we wish to only collect MS data or if we have any other detectors, for example an FID. We can also choose whether to collect data there. So for this video I will just choose MS. Here we can decide the different channels. So this is the data acquisition, so we'll definitely need this ticked. We then have post-run processes as well. So this is the reporting and data processing. So for this video I will untick those. These can be added or removed at any point. So I can now click Next. This is now going to show, it's going to add the GCMS and the GC. So finish. So this now pulls through the method. We can add notes within this Note tab. It then gives us an overview of the MS and the similar view here. And then the acquisition method is how we will collect our MS data. I will leave this till the end, and first I will fill in the GC parameters. So here it shows us our overview of the GC. And again, the same view here. If we then go to configuration, you may see this message. So it will tell you that the setup is not compatible. Would you like to adjust it? So we will then say yes, and this will pull in the configuration from the GC. So on this particular one I have 3 injectors and an FID, as well as an auto sampler. So this is all shown here. I can now set the auto sampler conditions. We can either use our standard splitless conditions, or we can use our user-defined conditions, which gives us access to a much greater number of parameters. If we want to use an internal standard, an air gap, and then we have here more user-defined. We can play with the injection speed, pre and post injection delays, the number of fill strokes. All these different things can make a difference with your analysis, and so you may want to consider this. So for now I will just set it to basic standard splitless. We can check how many pre-injection solvent flushes we do, if we want to flush the sample, and post as well. So usually I would do 3 pre, 1 sample, and 3 post. Sample delivery. This is if we have any gas sampling valve ovens, which this system does not. So simply valve oven installed no, so we can ignore this tab. The injector. This is where we would set the temperature for the injector. Be careful on a system with multiple injectors like this one. You may want to, well, depending if you have a column installed or not, you may want to keep them heated and keep the flow on, or you may simply just want to turn them off if they're not in use. So for example, this system now, I'm just using the front SSL. I want to have a temperature of 200. And then I can set the split ratio here as well by clicking split ratio. So if I was doing a split injection, I could have, for example, 20 to 1 split. We can add various programs here as well. So if we're doing splitless, we could add the splitless time, or we could have a gas saver mode. So say, for example, we had a very high split ratio at the beginning. After a few minutes, we could then drop the split ratio in order to save gas. And we can remove these easily. So we'll set a basic 20 to 1 split. I can then save that. I can then move to the flow/pressure option. Again, note if you have multiple injectors, you may wish to simply disable them if they're not in use. If they have a column installed, you may wish to keep the flow through them in order to preserve the life of the column. So I'm just using the front EFC. This is just the injector that I have a column installed on. I then have 3 options. I can choose manual, which is constant pressure. I can choose constant flow, or I can choose constant linear velocity. We have then some further settings. So for example, in constant flow, we can set the column flow here. We can also set a pressure pulse if we were wanting to do a pulse splitless injection, for example. If we had a backflush enabled, we can also set that here as well. This is just popped up. Although I'm not using it, it's telling me that the values are wrong, so I'm just going to set a nominal value, which then allows me to move on to the next screen. Now to the column oven. If we have cryogenic cooling or air cooling, we can add this, which temperature we wish to enable it at, and the time for it. So I have none, simply off. The stabilization time is the time between injections that the system will wait to stabilize the oven. The default is 2 minutes. You may want to make this shorter. We then want to ensure that the column oven is on. We'll then set our starting temperature. We may want to hold this for a couple of minutes, and then depending on our analysis, we may just want a single ramp, making sure to not exceed the maximum temperature limit of our column. And then we can set the rate that we wish to reach this temperature at. And again, if we wish to hold it, we can have multiple ramps. So for example, we may wish the initial to be much slower and the later to be much faster in order to decrease our runtime. It will depend completely on the analysis and on the application. The detector. This will only be set if we have other detectors that we wish to make use of. So if we want to collect FID data as well, for example, then we would need to set up the parameters here. The temperature, the flows, etc. Output is only if we have any outputs enabled, different sources. So for this example, we can just ignore this. Data acquisition is talking about the chromatographic data. So our FID, MPD, etc. as we can see here. And we can set the different data rates if we wish to collect that data. Auxiliary EFCs, if we have them, so this would be, for example, for backflush, things such as that. And then auxiliary heaters, again, if we have those, which we don't, so we can ignore that. So now that I have the GC parameters set, and I know that what my oven runtime is, I can now set my MS acquisition. So the main things to note here are if we click on this edit options here, we need to ensure that our instrument type is set to single quad. We can then use a collect delay, which is a solvent delay. So depending on the solvent, you may want to set this for a couple of minutes or 3 minutes in order to not be scanning. The detector and the filaments will be turned off at the point of the solvent passing through the system, which will help preserve the lifetime of the detector. So we can then apply that. Okay. Now we can set our scan time. So here we can choose between Fullscan and Sim. So I'm going to set this as Fullscan. We can then set the scan time. Typically for Fullscan, we want to set that to say 250. Sim, more like 50. We can then name this if we want individual compounds, and we'll see that in a different video where we talk about sample lists and more complex method building. For basic Fullscan, you can just leave this as default or name it as Fullscan. And then here we can set our mass range. So the first mass, the lowest mass that we want to measure, and the last mass, the highest mass we want to measure. So for example, typically that could be, let's say, 30 to 300. It will depend on the compounds that we wish to look for. We can then set a start and an end time, which will set the scan time for this measurement. So my runtime is 9.25 minutes. I've currently got a solvent delay of 2 minutes. So let's say I wish to scan from, let's say, 2.5 minutes up to 9 minutes. This is where I think the compounds of interest will come, so I can set that as my scan time. I can then save the method. We can direct it to any directory that we wish where we can save it. And then we can name this method, test01, and then save. I've already made that, so we can either overwrite it or rename a new method. Now that my method is ready, I can either load this into a sample list or the inject single sample. And again, we have videos on those, so please watch those to see how to do that. We can also activate the method. So we can go to File, either Activate Method, and find it in the directory, or we can file Activate Last Edited Method. This will then show us this method here, test01, yes. We can then click OK. We will then see that the method is loaded here and that the system is now in a not ready state as it transfers the values and waits for the GC temperatures to reach. So the MS is now ready, the GC will be changing temperatures and flows and will then become ready.